Alright, let's go ahead and we're going to solve a problem using the law of cosines, and this time we have a visual example. It wants us to find the length x of the diagonal of this quadrilateral. Now there's a question that's similar to this in your book, but it uses a parallelogram, and here we're not told that this is a parallelogram, we're not told that it's a trapezoid, all we know is it's a quadrilateral, so we can only solve it using properties of quadrilaterals, so we can't use parallel lines or anything like that because quadrilaterals in general aren't guaranteed to have parallel opposite sides. So what are we going to use? Well, let's first take a look at what we're trying to find. We're trying to find the length of this diagonal x, okay? The full diagonal. I know that the way it's labeled is a little deceiving, but for x they want the length of this full diagonal here. Okay, well, if we are given two of the sides for a triangle, if we formed a triangle here, but what's missing? Well, we're missing a little bit. We're missing an angle or another side to go with it. We can't solve if we're just given two of the sides because, again, this is not necessarily a right triangle. So instead what we're going to do is work to find the angles here and here so we know the size of this angle, right? And then we can use the law of cosines to find our missing side. So that's our end goal, and that's our method that we're going to use. So the first thing I'm going to do is I'm going to go ahead and split this into two pieces. Okay, so I'm given this diagonal here, and notice I'm given all of the sides. So if I split this and I just use the lower half of this quadrilateral, or the left half, I know this diagonal is length 8, and I know the bottom here is 7.6, and that this side is 3. Now we have 3 sides, so what we're going to do is we're going to see how this angle is split into two pieces. I'm going to call this angle A, and I'm going to call this angle B, and our job is to find A and B so we can then put them together to find the full angle. Well, here I have angle A in this drawing, okay? And I'm given 3 sides, so I know I can use the law of cosines to find that angle. And I'm going to also split off the top half here. Okay, so again we know the diagonal here is 8, and then the top side was 6, and the right hand side here is length 2.4. And again we want this angle right here, angle B, which is located here. So I've just kind of split it into two pieces, and I'm going to use the law of cosines to find the angle A and angle B, and then we'll be able to put it together here in the middle. So let's start with this left hand piece. I have angle A, so according to the law of cosines I start with the side opposite that, which would be 3. So I have 3 squared equals the other two sides squared and added together, so 8 squared plus 7.6 squared minus 2 times those two sides, so 7.6 and 8, times the cosine of my angle, which was angle A. Okay, from here we need to do some simplifying, so let's do all of our squared items. So we know 3 squared is 9, we know 8 squared is 64, 7.6 squared is 57.76. I can do my multiplication here, so 2 times 7.6 times 8 is 121.6. Okay, and now we're going to work on solving. So let's go ahead and put our like terms together. Here we have a 64 plus 57.76. That gives me 9 is equal to 121.76 minus 121.6 cosine A. We want to get cosine A by itself, so the first thing we're going to have to do is subtract the 121.76 from both sides. And that gives me negative 112.76 is equal to 121 equals negative 121.6 cosine A. It's multiplied by cosine A, so we're going to divide both sides by negative 121.6 so that we can isolate cosine A by itself. And that gives us .9273. Again, I'm going to leave the full number in my calculator, but this is approximately what we have, equals cosine A. So we need to solve for A again, and it has cosine with it. So we do the inverse of that, which is cosine inverse, or arc cosine of both sides. And that leaves us with angle A is about 21.98. I'm going to go ahead and round that to 22 because 21.98 is very close to that. So we found angle A is 22 degrees. So this angle, this portion here in our quadrilateral is 22 degrees. Now we're going to come over here and do the same thing to find angle B. Okay, so we're going to go through those same steps, go through the same routine, and get our angle B. So again, we set up the law of cosines. Again, our goal is to find angle B. So with the law of cosines, you start with the side opposite the angle you're looking for. So in this case, 6. So we have 6 squared equals the other, so it's equal to 8 squared plus 2.4 squared minus 2 times the two sides squared multiplied by each other. So 8 times 2.4 times the cosine of our angle B. Let's do some simplifying here. So 6 squared is 36 equals 8 squared is 64 plus, all right, that's a rough looking for, 2.4 squared, which is 5.76, minus, we have our 2 times 8 times 2.4, which is 38.4. And that is times cosine B. We do some simplifying, so let's go ahead and add our like terms here. 64 plus 5.76 is 69.76. So we have 36 equals 69.76 minus 38.4 cosine B. We're going to go ahead and subtract 69.76 from both sides. So 36 minus 69.76 gives me negative 33.76, and that's equal to negative 38.4 cosine B. We need to get B by itself, so this is multiplied here, so we do the opposite and divide by negative 38.4. And that gives us 0.8791 and then 66666. Again, I'm going to leave the full thing in my calculator, but for writing purposes, I'll write down this much of it. And now we're one step away from finding B. We just have to do the inverse cosine or arc cosine, whatever you prefer to say, of both sides. So if we do the inverse cosine of that value, I get about 28.5. Okay, so remember we were doing this to find our angle here. So far we know A is 22 and B is 28.5. So together, that full angle if I add 28.5 and 22, I get 50.5. Okay, so this section right here, this angle, is 50.5. And how does that help me? Well, now notice if I look at the diagonal I'm trying to find, okay, it forms a triangle on this side. And for that, I have 2 of the sides and the angle between, which means I can use the law of cosines to find my missing side x. Okay, so this time with my law of cosines, I know my angle is 50.5. I'm trying to find the side opposite. So when you're using law of cosines, you always start with the side opposite the angle. In this case, it happens to be x. So I have x squared equals the other 2 sides squared and added together. So 2.4 squared plus 7.6 squared minus 2 times my sides, so 2.4 and 7.6 times the cosine of my angle, which was 50.5. And I'm sorry, that's really rough. I'm going to rewrite it right here really quick. Okay, so this is just for neatness purposes. I know it's tough, and we're trying to do this on just one sheet of paper. Okay, so now start planning. What would our plan of action be as we go to solve this? Okay, notice our variable we're solving for is already by itself on the other side of the equation. So really all we have to do is calculate the value of the right side of the equation and we'll be good. Okay, so go one step. I suggest going one step at a time just because it can be hazardous to just type everything into your calculator and hope that it comes out correctly. So I'm going to go one step at a time. So I'm going to start with 2.4 squared is 5.76, and 7.6 squared we know is 57.76, minus 2 times 2.4 times 7.6, okay, and which gives me 36.48. And I'm going to go right ahead and multiply that by the cosine of 50.5, okay? And when I do that, I get 23.2, okay? All right, so now all I have to do is calculate this side, and okay, and notice we have an x squared still, so we'll have one more step after that. So we're going to go ahead and add 5.76 plus 57.76 minus 23.2, and that gives us 40.32. And then again, our last step, we have an x squared, so we would take the square root of both sides to find our solution. And the square root of 40.32 is about 6.349, so about 6.3. So we have finally found the solution of this problem. We had to use the law of cosines to find this bottom portion of this angle. Then we use the law of cosines once again to find the top portion. We put those two pieces together to get an angle of 50.5, and finally we use the law of cosines once again to find the measure of this diagonal.